Kia ora tātou. In this video we're going to look at ion formation and electron configurations. So we'll look at the periodic table again, and just to choose an example we'll go with oxygen. We'll look at the ion formation of oxygen. So first of all let's draw the atom, an oxygen atom. So oxygen has the atomic number of 8, so that means it's going to have 8 protons in its nucleus. So atom of oxygen. Let's make this a bit neater. So we're going to do oxygen. Oxygen is the title, and we've got an oxygen atom. So it's got 8 protons in its nucleus. So that means that when it's an atom, it is going to have 8 electrons in its shells. So we're going to have 2 electrons in the first shell, and then we've got 6 electrons to put around the next shell. 3, 4, 5, 6. So the thing about atoms is that they are more stable when they have a full outer shell. So a full outer shell means that there's the maximum number of electrons in the outer shell. So if we drew the shorthand the electron configuration of the oxygen atom, we would go 2, 6. So there's 2 electrons in the first shell and 6 in the second shell, but the second shell has a maximum of 8 electrons. So we can either gain or lose electrons in order to gain a full outer shell and become stable. So in this case, oxygen could either gain gain 2 electrons, or if it was to lose 6, that should just be a negative charge. Or if it was to lose 6 electrons, that would have a full outer shell because that would be down to the inner shell with just 2 electrons. So it's going to choose the one that has, well, it doesn't choose, but what would happen is that it would gain the 2 electrons because that requires less electrons than losing 6. That would be really hard to do. So we could draw the ion of the oxygen atom, which will have still 8 protons in its nucleus, but we're now going to gain 2 electrons to form that full outer shell. So 1, 2, and then we're going to have 1, 2, 3, 4, 5, 6, 7, 8. So this has now got 10 electrons in total around the outside. So O, the ion, has now got 8 electrons, and it's only got 8 protons. So this is going to mean that this ion is going to have a charge, because electrons have got a negative charge and protons have got a positive charge. With normally when the elements are in their atomic form, we would have the same number of protons as electrons, and so those charges will cancel out. But we no longer have an equal number of protons and electrons. So what's going to happen is that we have 8 positive charges, but we have 10 negative charges. So if you go 8 minus 10, so take the negative number, go positive 8 minus 10, that's going to equal negative 2. So overall, this whole ion is going to have a 2 minus charge. So the way that we would show that in the symbol, because when we do O, all we see is that there's no way to differentiate at the moment between an oxygen atom and an oxygen ion. So we draw the ions by writing the charge up the top right hand side of the symbol. So O2 minus would be the oxygen ion, and then O just like that is the oxygen atom. So let's look at another one on the other side of the periodic table. Let's take sodium for an example. So we've got the atomic number of 11. So I'll see if I can do this neater from the start this time. Sodium, vanadium, sodium. Okay, so the atom has 11 protons. So we're going to have 11 electrons in its shells. So 1, 2, 3, 4, 5, 6, 7, 8. So we've used up 10 electrons so far, so we've got 1 electron left. So we need to put that 1 electron in its outer shell there. So this sodium atom has the electron configuration of 2, 8, 1. So this is slightly different to the oxygen because this could either gain 7 electrons to fill up this shell, or it could lose 1 electron to then have that second shell as its full outer shell. So in this case, it actually requires less electrons to be lost or gained if we lose that electron there. So we're going to choose this option there where we've got the ion. We've still got 11 protons in the nucleus, but around the outside of that nucleus we've got just 10 electrons. 2, 3, 4, 5, 6, 7, 8. Yeah, and that's it. So 10 electrons, so we've just got those 2 shells filled up, and you'll notice that the second shell is now full, so that second shell has got 8 electrons in it. So the sodium atom has an electron configuration of 281, and the sodium ion has an electron configuration of 28. So how do we find out what the charge on the sodium ion is? So we've got 11 protons, 10 electrons, so we've got plus 11 minus 10, so 11 minus 10 is positive 1. So we're going to have a positive 1, and we're just going to draw that as a plus. We don't need to draw the 1. In a plus, the sodium has a charge of plus 1. So those are atoms and ions. You can do them all the way up to number 20. You could practice with anything in group 1 or 2, or anything in group 16 or 17, any of those 4. Those are the most common ones that will come up in any exam. Okay, the things in the middle, maybe aluminium will come up, but everything else you won't really see needing to draw the ion configurations of them. Cool, thanks for watching this one. In the next video we'll look at how to name these ions. Cheers.